In this lecture, we're going to begin the first scenario of this course. In this scenario, we are playing the role of a back-end operating engineer for the red team. We're going to be supporting the exploitation efforts of one of the operators that's actively targeting a system for exploitation. Now, for all practical purposes, we will technically be demonstrating both of the roles, but our primary focus is on the engineer that is supporting the operation. The operator's role is to gain initial access and call back home to a C2 server that we have established. Once that is successful, it's up to us as the backend engineer to perform some post-exploitation with the new shell that our operator just planted for us. So, from the operator's perspective, it looks like we found a target on a network that is likely vulnerable to MS-17.0.10. This particular engagement is testing how well our target holds up against standard, out-of-the-box tools like Metasploit. And so far, it's just not going too well for him. An auxiliary scan seems to point us in the direction of MS-17.0.10, and our operator is ready to exploit the system. Now, normally, our operator might be able to start a local listener and just call back to their laptop. But the only reason that they're able to see the systems they can see right now in this situation is because they are physically on location exploiting this local network. This means if they're caught at any point for any reason, we could lose our access. If all the shells are going back to their local systems and their laptops get cut off, we lose that access. So we need to set up some kind of command and control for them to craft their payload to call home to. Since we are using Metasploit to service our C2 in this scenario, we have quite a few options. We can simply load up any kind of Linux server and install Metasploit, call it a day. Fortunately, Kali Linux does maintain an official AMI for AWS instances. This means, with a little bit of Terraform, we can be up and running with a basic C2 server that already has Metasploit ready to go in one foul swoop. The Terraform code that I have here pulls the Kali AMI, then sets up some remote access stuff for SSH, and opens up a couple different ports for egress, so we have a few different strategies to get out of the network for reverse shells. After all that's set up, it'll display the IP address of the C2 server, so that way we can SSH into it. As you can see, I've already ran this. It does take a little bit to run because there's some extra scripts in there that are installing things like Empire and Merlin, which will be useful later on in this course. So I do recommend you running this Terraform if you want to have that preset up for later on. But ultimately, it does take a minute. So I've already ran it, and I've got this set up and prepped and ready to go. That said, I still need to log into the C2 server and actually set up our command and control. So we're going to log in, and one of the first things that I like to do on initial login is start a new tmux session. So what tmux is going to do for us is keep our console alive with Metasploit running and keep all our C2s, talking back and forth and communicating, even if we get disconnected for any reason, whether we fat finger a command or we lose internet, our C2 server will still be up in the cloud, receiving connections and maintaining that access. So tmux is going to help us facilitate that. Now that we have that, we'll run MSF console as root to start Metasploit. Now, you may ask, why are we running as root? Well, Metasploit itself is usually a privileged application. You can do many things without escalated privileges, but many of the networking niceties and some of the module features may crash without proper permissions. Now, you can technically set the appropriate network permissions to solve some listener problems, but ultimately, even though it's not the finest practice, it's also not necessarily wrong to run it as root. This is one of those scenarios where we as a red team don't always have to follow the best standards because some of them just simply don't apply to our tool sets. That said, if you do need to run Metasploit in a specific configuration as a specific user or with specific controls in place, you can completely control and tweak these things. Running it on Linux and Metasploit itself, it's all open source, so you have complete control over everything that you need. So feel free to harden it to your heart's content, but for sticking to our basic scenario for now, this will work just fine. There's no harm. So we're going to start up our multi-handler. So we'll say use exploit multi-handler. And now we need to set a payload. So our operator sent back some recon data from that check, and we know that it's a 64-bit system and it's Windows 7. So we know we need a 64-bit Windows payload. So awesome. We're going to configure our listener now for port 80 on a reverse TCP payload. So we'll say set payload Windows 64 interpreter reverse TCP. Take a look at those options. All right, so for our L host, we're actually going to want to set the L host to the interface that is going to be exposed to the public IP on the internet in AWS. In this case, it's always ETH0. You can take a look at an if config real quick to see that. As we can see, E0 is this 172 address. This maps to the public IP. And then we want to set that L port to port 80. There's one more option we want to set. We want to set exit on session to false. This way, the listener keeps going and keeps listening for even more shells even after we've disconnected. This is going to be useful a little bit later in our post-exploitation, so we already have our listener running. So we run exploit-j to actually have the listener running, and now we're great. So you may be asking, why are we choosing this payload? How did we come to this conclusion? Well, the first two pieces of information came from our scan results. Thanks to our recon, we know this system is likely running Windows 7 and is a 64-bit system. Okay, but why the choice of TCP? Why not an HTTPS payload? We see, in this scenario, technically every standard Windows payload will work, but during testing of the target environment and network settings, the DNS and HTTPS configurations made it difficult for this system to connect outbound over 443 to our system. So, instead, we are using port 80 as a common web port for egress, and our payload is still encrypted since it's interpreter, but there could be more artifacts to be gleaned without TLS. Even without using HTTPS or HTTP, we still want to use a domain name for our C2 host. This way we can easily bring down our C2 server and set it up elsewhere and just point our domain at it again to catch the shells. So in this case, I'm going to use my injection.sh domain to create a subdomain to test our C2 in this lesson. So I've already configured in my registrar DNS to point from udemy-c2.injection.sh to my C2 server's IP address. Now our operator can actually use this in their payload to get a callback. So we've got our multi-handler running and it's ready to go. And we can come back over to our operator and check out our options. Looks like they've got their payload successfully configured to go to the proper udemy-c2.injection.sh host and on port 80. So now we can exploit this and hope we catch a shell. So I'm going to switch over to our C2 view to see if a shell comes in. Awesome, interpreter session 2 open. Now we're going to act quickly because this shell can be a little bit unstable and we actually want to migrate to a more stable process. So we're going to take a look at our process list and I'm going to look for an SVC host that we may have access to. Looks like this one's running a system on 1364. So we'll migrate that app process. Awesome, migration was successful. So we'll background that for now and come back to it. Awesome, our attack was successful. We got a system shell. And now we're ready to start the post-exploitation side of the scenario. I hope you all have learned a lot, and I'll see you in the next lecture.